Welcome back to Maths with Mrs. J. We've been doing a series of videos about the unit circle. The last couple of videos I talked about what I refer to as a horizontal reference. So just to recap, what I mean there is we're taking this triangle with the acute angle theta and we are flipping it over here, then reflipping here, or flipping over here, so that the theta, whether it be in degrees or radians, is always going to be next to your horizontal axis. So if you're talking about radians, you would be pi minus theta, or pi plus theta, or 2 pi minus theta, or just minus theta. In degrees, it'd be 180 minus theta or 180 plus theta, that sort of thing. Let me just pop on this diagram our vital information, which of course is where our pi, it's not quite thick enough, is it? Where our pi is. So that's pi on 2 here. A bit hard to find a space to pop it, but we'll pop it there. This is 3 pi on 2 here. And this is either 0 or 2 pi. Okay. As you can probably guess from the diagram that I've got here, in this video we're going to be talking about what I refer to as a vertical reference. Not hard to see why I refer to this as a vertical reference. So what we've done here in each case is we have put this angle, whether it be in degrees or radians, next to this vertical or y-axis. So in this case, you would be talking about this position on your circle as pi on 2 minus theta. All right, this here would be pi on 2 plus theta. This would be all the way around to 3 pi on 2 minus theta. And this point here would be 3 pi on 2 plus theta. Let's just remind ourselves about our sine, cos and tan of theta. So we know that sine of theta is the y value, which here is b. Cos of theta is the x value, which is a, and tan of theta is either, you can think of it as sine on cos or the y value on the x value, same thing. All right, now I said that we talk about this point's position as being pi on 2 minus theta. Let's just think about this for a minute. So sine of pi on 2 minus theta, cos of pi on 2 minus theta, and tan of pi on 2 minus theta. We want to think about how these relate to what we already know. Well, sine here is the y value, which is actually going to be a. Let me just say that again. Sine here is the y value, which when you read across is a. Now, a was our cos of theta. Cos at this point here is your x value. And because you've gone across by b, it's going to be b. And that's in fact the same as sine of theta. Tan is going to be a on b, which is the reciprocal of tan of theta. We call that cotan. We just write cot. Let's see what happens in quadrant number 2. So here we'd refer to this angle. I might just get rid of this bit here because that's sort of in my way. Okay, so we'd refer to this angle as pi on 2 plus theta, wouldn't we? So sine pi on 2 plus theta, cos and tan. All right, well, what's the sine value here? Well, it's the same as what it was there, which is a, which is the same as cos of theta. Cos here is the x value. We've moved b to the left, so it's negative b, which is the same as sine of theta, but it's negative. And tan is going to be our sine divided by our cos, which is negative a on b, which is negative cot of theta. Let's have a look here. What's happening here? Well, we're going around, all the way around by 3 pi on 2, and we're coming back by pi. So these angles we'd refer to as 3 pi on 2, not coming back by pi, coming back by theta, I should say, sorry. 3 on 2 minus theta, cos of 3 pi on 2 minus theta, and tan of 3 pi on 2 minus theta. Let's see what we get for these. Okay, well, sine here is the y value, which is down at negative a. That's the same as cos of theta, but it's negative. Cos here, you've gone b to the left, that's your x value, so it's negative b, which is the same as sine of theta, but it's negative. Tan is your sine divided by your cos, which will give you a positive a on b, which is positive cot of theta. All right, the reciprocal of tan is cotan. And this point here we'd refer to as 3 pi on 2 plus theta. So let's have a look at what happens there. Hopefully you're seeing a bit of a pattern developing here. All right, sine value here is your y value, which is negative a, which is negative your cos of theta. Cos here is going to be b, which is exactly the same as sine of theta. And tan here is going to be negative a on b, which is negative cot of theta. Now, as I said before in previous videos, absolutely do not sit down and try to learn those off by heart. What I want you to do instead is to actually understand what is happening. Now, what is happening is because we have basically flipped over this triangle to here, what was your x value has now become your y value, and what was your y value has now become your x value. So basically your sine and your cos swap. Now, because sine and cos swap, when you do sine divided by cos, you're going to get the reciprocal of tan, which is cotan. Now, to sum this up, it's actually really, really easy. All we've got to do is we say, well, if you've got a vertical reference, the trig ratio swaps. Now, what I mean by that is that sine and cos swap with each other and tan and cot swap with each other. The actual sine, S-I-G-N sine, still comes from all stations to central, like we did with our other one. We know that in our first quadrant, everything's going to be positive. In our second quadrant, the only thing that's positive is going to be sine, etc. The only thing that's going to be positive here is tan. Well, because cotan is the reciprocal of tan, obviously it has the same sign as tan. And the only thing that's going to be positive here is going to be cos. Now, in the next video, we're going to do some mixed examples of both horizontal and vertical reference. And I'm going to show you how simple it is to just ask yourself a few questions, maybe draw a little sketch, and you can work this out very, very easily. Absolutely no need for rote learning.